Welcome back programmers. In the today's section we are gonna focus on TensorFlow. So this is the huge video for beginners. If you wanna learn TensorFlow, machine learning, artificial intelligence or data science, so this is gonna help you. So this is the huge video for TensorFlow or machine learning lovers. So in the today's section we are gonna check out some basic stuff of TensorFlow. And first thing first, if you don't know about anything, what is NumPy, how to use NumPy, Matplotlib, so first check out Matplotlib and NumPy and then come here, link is in the description. Because if you wanna learn TensorFlow or machine learning or artificial intelligence or etc, you have to learn some few basic things like NumPy, Matplotlib, SciPy. But for today's video you want to just learn NumPy and Matplotlib. Matplotlib is not important, but first learn NumPy. Okay, now let's begin for beginners. You can see this is the TensorFlow for Dummies, a Willy brand by Matthew Scarpino. This is a very famous book for TensorFlow. From this book we are gonna learn something basic stuff. Okay, now let's begin. I'm not gonna go in the theory part, I'm directly gonna go in the practical part because theory is not important. Theory is important, but I'm gonna give this book, link is in the description, check out all theory. I'm gonna focus on practical. Now obviously when you want to use TensorFlow you have to install, so the code is pip install TensorFlow or pip3 install TensorFlow. If you are using Anaconda you don't need to install. We are gonna use Jupyter notebook for this video. If you are using Linux, so just add sudo apt get install python pip python dev and then sudo install pip3 python dev and then sudo pip install TensorFlow. Okay, this is my Jupyter notebook. First you have to import the TensorFlow. You can see import TensorFlow as TF. Now what is TF? TF is my pal name, buddy name. You can name it in here anything. I'm gonna just call TensorFlow TF. You can call it anything. This is my buddy name or you can say pal name. Okay, when I run this with shift plus enter, it ain't got any error, it means it run successfully. Okay, now let's find out the version of TensorFlow, and for that I'm gonna use tf dot. We are gonna simply use version. Okay, I'm gonna run this and you can see I got 2.0.0. now if you are watching this video in future, so it means your version is very different, so it doesn't matter what version is this. We have to just learn some basic and important function of TensorFlow. Okay, now that we know version, okay, now let's just focus on tensors. Now what is tensor? Book link is in the description, check out. First we are gonna learn constant. Now what is constant? So TensorFlow has some few constant available, like, so basically what constant means? Constant means its value never changed. Value never ever change. For example, a equal to 10. If I create a equal to 10 is constant, so it means a is 10. Its value is never gonna be changed. But I ain't create constant for a. If I create a constant, so 10 is never ever gonna change. We can't change constant. So basic stuff. If you know C, C++, so you know constant. Okay, now let's create constant, and for that I'm gonna just first mark down constant. Okay, in here we are gonna just use tf dot constant. Now let's create constant. You can see the function constant is take a few parameters. First one is value, then data type, shape, name, verify shape, so on so, but the main parameter is value. Okay, now let's use constant. So first I'm gonna create a comment line constant. Now let's create a variable a equal to tf dot constant. Okay, now the first parameter you want to pass is the value. So value, you can pass anything. I'm gonna pass 3. Now let's just print a. You can see we got tf.tensor 3, shape is 0 and data type is integer 32. Now this is our constant. So we can change value to, like if I want to create a 3-dimensional array with 3 lists and 3 elements, you can see we got shape equal to 3. Now this is not a 3-dimensional array, so this is just a tuple. So if I create a 2-dimensional array, if you know how to create a dimensional array, or you can pass a numpy in here too, but I'm just gonna use the list 1 2 and 1 2. You can see the shape is changed into 2 by 2. Now if you know numpy, so you know how this work. You can see we got 2-dimensional array with 2 lists. Now let's create a numpy array in here. So I'm gonna use ones for create a 1 array, and for that I'm gonna import numpy is np. This is my body name, pal name again. Okay, so in here I'm gonna create numpy array, or you can say matrix. Okay, let's create ar equal to np dot ones. I'm gonna use ones, and I'm gonna add a shape in here. So let's just say 3 is good, and data type equal to, I want np dot uint 8 is good for now. Now let's just first print ar. You can see we got a list. If I change 3 3 3, you can see we got 3-dimensional array with 3 lists and with 3 elements. Let's say I want 5 elements in per list. Okay, this is my array with all 1 1 1 1 because I used 1. Okay, now let's just print a. Okay, you can see in here I just passed a list, but I'm gonna just pass ar. Okay, this was my mistake, ar. So this is my constant array, you can say constant matrix, tf.tensor, shape is 335, which I passed in here, and data type is uinteger 8. Now if you want to change the data type in here, like d type equal to, if I say np dot integer 16, so you can see the data type is changed to integer 16. So that's how you can create a constant. So this is the constant, it means the value of constant never changed. Okay, so I'm gonna remove all of this stuff because we are gonna use a simple equation for our constant. So in here I'm gonna just use a number, like I'm gonna first change this constant variable name into con, and I'm gonna remove all of this stuff. Okay, so first I'm gonna create a variable a equal to 10 and b equal to 20. So this is my constant, remember this is my code term constant. In here I'm gonna first pass a and I'm gonna choose data type equal to np, or you can say tf. tf has a lot of data type available. You can see boolean, integer 8, integer 6, quint, integer, quint, float, complex, string, and so on. So if you wanna use tf dot, let's say integer 16, so you can use this. So I'm gonna first print the a. You can see a is 10, but let's print the con. You can see we got tf.answer.10 and shape is none. Okay, so that's how you can pass the single value in constant. But now let's first remove all of this stuff. Let's create a equal to tf.constant, and in here I'm gonna pass the value 10, and I don't want to pass the data type. I want to pass the name, so name equal to, let's say, a, and in here I'm gonna copy this, paste this, and change the variable name to b. Okay, a has 10 and b has 10, so a value is 10 and b value is 10. Now what if I create another constant, or you can say another variable, c equal to a plus b. Let's print c. You can see we got 20. Now this is constant too, because constant plus constant equal to tf.tensor 20. This is another constant c. So that's how you can create a sum. If I do this minus, you can do this. If I do multiplication, you can see we got 100, and then division and module, so on. So okay, now TensorFlow has own function. Let's say c equal to tf dot, if we want to multiply, so we got a multiply. You can see we got multiply, and in the parameter just pass a and b. Let's print c. You can see we got 100. So that's the same stuff. Now you are thinking why we need a multiply function. We can just do like this, a into b. But no, what if you want to multiply the whole array or matrix? Let's say, what if I want to multiply these 2, 3, 1, 5, 6, and in here again 2, 1, 4, 8. This is random number. I don't know what am I writing. So this is a totally random number. Let's print this. You can see 2 into 2 4, 3 into 1 1, 3, 4 into 1 4, 5 into 8 these, and 6 into 8 48. Okay, so that's how you can, let's change the value to, that's how you can multiply stuff. If I change the multiply to subtraction, you can see we got this value. This is a subtraction. If I say division, divide, so this is the divide function. So that's how you can sum, multiplication, division, module, whatever. If you want to do, just do this tf dot, use the function and pass the value. So that's how you can do the equation. Okay, now I don't want to see this, I want to see the c shape. What if I want to only see the shape of c? So simply just write c dot shape. You can see the shape of c. Now if you don't know what is shape, just check out my NumPy video, link is in the description. Check out my NumPy full series, because this is very important if you wanna learn machine learning, artificial and data science, so on. So now let's just print again c. If you wanna see C of data type of C. So just type C dot D type. Let's try C dot D type. You can see float 64. You can change the data type to. Okay, now let's change to C. Now what if you want to see only the output, and for that you have to use session. Now what is session? In the next video I'm gonna talk more about in session in the deep, but let's just say session is our output. We got input, this is our input, and session is our output, and for that we are gonna use session. So I'm gonna just use, first I'm gonna cut this. Remember I cut that. Okay, so I'm gonna use with tf dot compact dot v1 dot capital S session, as you can name it anything, SESS. In here I'm gonna just paste all of this stuff, and I'm gonna create a session. Okay, and for that SESS dot run ses dot run C, and I'm gonna run this ses into print statement. Okay, I got an error, enter error. This is attribute error. Now the error is because I forgot to put tuple in here. You can see we ain't got error. Now I'm gonna print again SESS dot run, and I'm gonna pass this C because I want to output C. Okay, you can see we got 1, 3, and this is the divided. I'm gonna just change into summary. Sorry, summary is another function I'm gonna talk more about in later video. Subtract. You can see 2 minus 2 is 0, 3 minus 1 is 2, and 1 minus 4 is minus 3, and so on. So this is our output, this is our session. So basically session is nothing but our output. In machine learning, in neural network, we are gonna learn more about in session how to get output from our equation. Okay, now that we know constant, let's create a zeros. So that's all our constant. Now let's create a zeros. Now what is zeros? If you know NumPy, I talked about zeros before, so I'm not gonna talk more about in this video. I'm gonna just use the zeros using tf. So let's say x equal to tf dot use the function zeros, and in here you can pass the shape 3 3 3, and basically data type equal to, let's say tf dot integer 64, and I'm gonna just simply print the x. Now this is our tensor which created a zeros matrix using zeros function. So in here you can see all of the elements are 0 because we used zeros. Now if you want to create a 1, so you can say ones, you can use ones. So all of the elements are ones. So I'm gonna change it to zeros and ones. Okay, that's how you can create zeros and ones. Y equal to zeros. So this is our ones and this is our zeros. You can see the shape is 3 3 3, 3-dimensional array, 3 list and 3 elements. If I change to 5, so the element is changed into 5 elements. So watch NumPy to learn more about what is shape, how to use shape, how to use reshape, how to use NumPy. Okay, now that we know ones and zeros, now let's talk about fill. So basically, if you know NumPy, there's nothing to talk about. Let's say x equal to tf dot fill. So basically, all the function which include in NumPy, all of that function we can use in here too using TensorFlow. So fill is nothing but let's just pass the shape of list, or you can say matrix, and fill value is in here. Value is, let's say, 9. So let's print the x. You can see, oh, we got shape error. Dimension must be vector, got shape fill. Okay, so in here you can see I got 3-dimensional array with 3 list and with 3 element. All the elements are 9. If I change this to 18, you can see we got 18. If I change this into 34, you can see this is all of the elements are 34, but you can see the integer is 32. Data type is integer 32. What if I change the 34.21? You can see the data type is changed into float 32. But if I type dtype equal to, you can say tf.integer 60 or whatever, so the data type is changed and you only see 34 in here. So that's how you can use fill. Whatever value you can write in here, like if I write, you can see, oh, we got a error. Now let's see what is can convert Python sequence with out of range integer to tensor. Okay, so I add too much value, you can see. So that's how you can use the fill function. Okay, now the very important function line space. So in the NumPy video I didn't upload the line space and range video. So next day or in the future I'm gonna upload this video too. But let's see what is line space do in TensorFlow. This is very important function, line space. Now line space is create a linear range like np.arrange. Just define range and we just need to provide lower and upper, but in the line space we don't actually provide step size. It automatically calculates step size, we just provide numbers of points. So what I just said, before learn line space, let's just learn range, because without range we can't learn line space. Okay, so this is range. Now if you know Python, we got a function range 2. This is same as range, so I'm not gonna talk more about in range because this is the basic concept of Python. So let's just first use x equal to tf dot range. Okay, so the first parameter is lower bound and the second parameter is upper bound. Lower bound is 0 to 10. Let's just print the x. You can see we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I add 11 here, you can see we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 10. The shape is single, and if I change the value here, so 5, 6, 7, 8, 9, 10, so that is simply range. So this is range, lower bound and upper bound. This is lower bound and this is upper bound. Now line space is same as range, but in the line space we can't add a lower bound and upper bound. It automatically detects the lower bound and upper bound. Now how? Let's just create x equal to tf dot lower bound. But first let's just take a limit. So this is n. Now what is n? I'm gonna talk in later. Let's create a line space. Okay, so let's say x equal to tf dot line space, and in here just simply pass the parameter. Okay, so the first parameter is where to start and where to end. I want to start with 0. This is same as lower bound and upper bound, but I said you don't need to add a lower bound and upper bound. No, in here you have to add lower bound and upper bound, but it detects automatically. Let's say 0 to 10, 11. So it start with 0, same as the range, and go till the 10, same as in here range. Let's just first print the x. Okay, line space missing one, required position argument number. Okay, so you can see the line space missing one required positional argument number. In here you can see the parameter is start, stop, number, name. So what is number? Let's say this is our range 0 to 4. So in range you can see when you call the range, it creates like this 0, 1, 2 and 3. But when you call the line space, same as the range, this is our line space, this is our range, and this is our line space. So when you call the line space, you have to add one more parameter, that is n. If you say n is, let's say 5, or first the stop bound is 4, so let's just say 4. So if n equal to 4, so it create elements like this 0, 1, 2, 3. So n equal to 4, it means you can see in here, you can see the 4 element. But if you change the value n equal to, let's say 6, so what happened? If you change the value into 6, so the all element is gonna change. This is just for an example. It create very logically. So this is just an example. So when you add n equal to 6, so 6 equal to, it start with 0, so it create a 6 element 0, 1.1. This is example again. This is gonna create 1.1, 2.1, and again 3.1, 3.5 and 4. So that's how line space gonna create arrange elements. So it start with 0 and end with 4, just like range. But when you enter n, so it create a n number of elements. Let's just implement. So I add n equal to 10, so the element is start is 0 and element stop when 11. Okay, so I'm gonna just pass n. Okay, what is the error in here? Could not find the well device for node. Okay, this is the CPU error. I don't know what just happened. So I'm gonna solve this error. Later, but first in here I'm gonna just show you how line space work. So I'm gonna use np numpy. I'm gonna solve this error later. Could not find well device for. I just opened GitHub and solve error later. But first let's just quick use line space. So for that, let's say n equal to 10 and x equal to np dot same function line space and start with 0 and it 11 just like range, and in here I'm gonna just pass the n and then simply I'm gonna just print the x. You can see we got arrangement of element which start at 0 and end at 11. So that's how you can create a line space element. So if I change the value into 2, so you can see directly start with 0 and end at 11. So when I change the value into 4, it create a 4 element 1, 2, 3 and 4. It automatically create lower bound and upper bound. If I change the value to 100, so you can see it create a hundreds of element. You can see the value of element is 0.111111, 0.22222 and so on. So if I change the value in here 5 to 11, it start with 5 and end with 11. Okay, so that's how line space work. If I change the value to 999, you can see it create a element so on, so big, huge number of elements. So that's how you can create a line space arrangement. I don't know why TensorFlow doesn't work. Let's try again. You can see we got error, could not find well device for node. I'm gonna change these. I'm gonna solve this error later, but you can try TF2. That's how you can use the line space. Okay, now that we know range, fill, ones and zeros and constant, and let's just use the boolean, uint and so on. So data type, if you wanna use this data type, just do like this. This is just an example. You can use all of the data type. A equal to, you can even create an array using the numpy, and you can, let's say, array and even you can use the data type is, let's say, first I'm gonna pass the list 1, or I'm gonna pass the number only 10, and you can use tf.data type. So you can see we got a data type like boolean, uinteger 8, uinteger 16 and so on. So you can use any of the data type. Let's say uinteger 64, or if you use complex, you can see the result very changed. Let's just print A. You can see the data type not understood, means this doesn't know what is this data type. But if I change np.array into ones and 0, so you can see the data type, but it isn't support the data type of 10. Let's just say np.tf.uinteger 16. So this is the 10 is so data type not understood. It means you have to add np in here. So that's how you can use the data type. I just used np. You can use tf, but you want to use tf in here, tf.array and then tf.integer 16 or complex or whatever you want to use. You can see the output is changed because of complex 10 dot plus 0 dot j. So if you know mathematics, you know what is this. So that's how you can use the data type. Now learn all of the data type. What is boolean? Boolean is true or false basically. Uinteger it 8, unsigned integer and so on. So just learn all of the data types. Now that we know constant and We know how to use constant and what is constant, what is zeros and ones, and fill, what is line space. Now let's just use creating a tensor with random values. Now how to use random function in here? It create a randomly value by its name, you'll know. Okay, so let's just use first random normal function. So in here I'm gonna create a markdown for randoms. Okay, so the first one is random normal. Let's just say x equal to tf dot random normal. You can see we got random normal initializer, but we are gonna just use random normal. So the first parameter you have to pass is shape, or you can say element. Let's just pass 10, and then basically simply data type. Let's just pass tf dot complex. This is, I know, very huge data type, but let's just use this for now. Okay, module TensorFlow has no attribute random normal. So why this happened? Because in this book you can see we got lots of function like random normal, structured normal, random uniform, random shuffle. So why is this happened? And this is 2.02 TensorFlow, and you can see the same technique we used in our Jupyter notebook. tf dot random normal, and the first parameter is 10 and data type is 64 in float. So you can see in the Stack Overflow, TensorFlow 2.0 comes with new analysis for random normal using tf dot random dot normal instead of tf dot random normal should execute successfully. So it means it changed to random dot normal. So it run, but you can see the complex error because we used complex. Let's just remove the data type in here because I passed it 10. You can see we got a random element fully randomly. If I enter a data type like integer, tf dot integer 16 is good. You can see again we got error. Attempt to convert a value tf dot integer 16 with unsupported type class. Okay, so when you add the elements in here, it automatically detect the data type. If I print x dot d type, sorry, not a tuple, okay, x dot d type, you can see this is automatically call the d type float. Okay, if I change this to this, you can see we still got float. If I change this into only 1, I still got float 32. Okay, now let's just use truncated normal. So we have to use y equal to tf dot normal, sorry, random dot let's try truncated normal. Okay, in here first thing is shape again, and mean equal to 0.0. We forgot to use mean in random normal, and that's why d type is, you can see, float 32, and seed and name is doesn't matter, you pass or not pass. But let's just use a mean and stddev. Okay, in here I'm gonna first pass the list 10, and I'm gonna simply just print the y. You can see we got a randomly generated elements in here. Let's just try another parameter, mean equal to 0.0. So Have you noticed or not? I don't know, but when you remove the mean, you can see the elements is all of the element is same, but when you enter mean equal to 0.0, the all of the element is same, but when you change into 1, you can see all of the element are starting. Upper element is randomly generated with 1, and you can see you got a negative element 2. But if I add a 10 in here, you can see the changes. It create a randomly element to the 10 only, to the 10. If I add 100 in here, it create to the 100, 98, 99 and 100. If I change the 100.100, you can see we got 99 dot and 100 dot. Okay, so that's how you can add a mean to specify how much or to how many elements you want. Okay, let's just add 6. You can see we got 6, 4, 5 and we got 7 2. I don't know why we got 7, because I forgot to add dot. Okay, now let's just add 0.0. Now let's try std_dev equal to, let's say 1.0. It ain't changed. Let's try 99. Let's again try 60. Okay, 69. So in official TensorFlow site, you can see std_dev is a Python scalar of scalar tensor, standard deviation of the random value to generate. Okay, so that's a scalar to tensor, and mean is a Python scalar of scalar tensor, mean of the random value to generate. So seed is same as a Python integer used to create a random seed. And if you want to see the behavior, let's just add a seed in here. Let's add seed equal to 10. You can see we got a seed is 10. So that's how you can use a random. So in the next video, I'm gonna talk more about a random function and what is seed and shuffle, uniform, and I'm gonna talk more about in this stuff. And then we are gonna use a transforming tensors. So this is the beginners part 1. In the next part, I'm gonna talk more about it in TensorFlow, what is tensor, transforming tensor, creating operations, and so on. So till then, goodbye. If you like this video, like, share and subscribe to my YouTube channel. Share it to other programmers. If you want to learn machine learning, data science, artificial intelligence, OpenCV. So that is it for today's guys. See you guys in the next video. Thank you.